All right, so we are looking at lesson two, numeric data visualization. So we're going to start here with task one, which is comparing histograms, which is right here, box plots, and dot plots. So in looking at this, the question is, these are three plots of the same thing. It says, how many hours of sleep does a kid typically get? Explain your answer. Now, if I'm looking at, well, how many hours of sleep does a kid typically get? On the histogram, I'm noticing the mode here is between 7 and 8 hours. And then here on the box plot, this is a median, but the median is about 7 hours. And then here, the dot plot, you get the actual numbers here. They're hard to see, but this is a kid getting 2 hours of sleep, 4 hours, five, 5.5. One kid got six. Three kids got seven, and there's a count of them. So I'm going to answer here. I'm going to say about 7 hours. And then my answer would be I saw the median on the box plot. And then use the dot plot to find the mean, median, and mode of the data set. So in looking at here, what you would do is just find the mean by adding them up, the median and the mode. I'm going to show that in the numeric data file here. So rather than doing that by hand, I would have students do that by hand and then compare the answer with what they got on here. So first, mount the drive. So I'm mounting the Google Drive and waiting for the cell to run. The next thing that I'm going to do is import all the libraries. So I have the pandas library, the matplot, pyplot one, seaborn library, and importing all of those other things. Sorry that the advertisement part is coming up there. So next I'm going to import all of the libraries I need. Now what I'm going to do is import the data file as sleep. So in order to find the data file, what you would need to do is download this Excel sheet and then make sure you're putting the path to it. So how I do that in here is I go right here to the file folder, and then I'm going to my drive. And then here, this is one variable statistics with Python. We are in lesson two. I am getting the path for the lesson two data. So I go right here and I click copy path. And then in between my single quotes, you just print out your path. So you could have it in your download folder, whatever. And then it's just calling sleep the path. And then here I have the sleep hours, and then it has a separate one for the count. So what we're going to do is create a graph here of hours and then sleep hours. So it went on here, the hours, and then the sleep hours. And here it was, we wanted a sleep of class hours, and then we made a histogram. There were 6 bins, and the color was blue. So if you look here, it just made a histogram of this one. And on this one, if you notice here, we listed out each entry, but next to the ones here where we did a count for 2, the count was 1. For 4, the count was 2, and that was repeated for the other ones. That is used when we use the dot plot in Python, which is a little bit different than the graph I have displayed. So the next thing that we did was create a box plot. So we put data sleep, and then we did a box plot of the hours. And this SNS is just the seaborn library. And then a dot plot, we use the figure is from the Plotly one. It's a scatter plot of sleep. On the x-axis is the sleep hours. On the y-axis is a count. So it's not quite a full dot plot where each one has it in there. So you don't see on here what I'm talking about is it didn't make for four. It didn't put two actual dots here above it, which is what you see for other typical dot plots. But what it does show you is the count for each. So for 2 hours, one kid got slept for 2 hours. For 4 hours, two kids slept there. So it was the best version that was available on Python to make a dot plot. So in looking at here, if we're looking at finding the mean, median, and mode of the sleep data, so let me go back here to answer that question. So we created the histogram and all of those things. We would go back here. I sorted the values and I used the describe function right here of the sleep hours. So here is the mean. So I'm going to say the mean is 6.47 hours. The median is, I'm just going back here, 7 hours from the 50th percentile. And then to find the mode, we can go back to the sheets and then find where the count is the highest. So in looking on here, the highest, the mode is 8, and then 7 has 3. So there are 2 modes of 7 and 8 hours. Now, in comparing and contrasting these, which data best represents that? That's more of a preference one, but I like a box plot. You can see the median on the box plot, the range on the box plot. You can find the interquartile range, like most 50% of the students slept between 5.5 and 8 hours a night, and you can see that quickly on here. What you don't see is each individual data plot. So the dot plot, you could actually calculate your statistics for the individual data there. The histogram is valuable for the shape of the data. So if I looked at this has some skewing. The data, if you look here, is kind of a little bit skewed left. What I mean by that is there's a few kids that sleep very little in the class, and that's giving a skew or tail to the data set. So I would think the box plot is the best representation of the data, and because you can see that data the best. So to make a histogram here, what you would do is just make a frequency table where the data is between 2 and up to 3 hours. So if I did a count of the number of kids that had between 2 and including 3 hours, so on here I look, there's 1, kid that slept between 2 and 3 hours. Now this would be starting at 3, but not including it to 4. So like 3.5 to 4 hours. So I'm looking here's 1, 2, and I would put 2 for that. So you just continue that count in there, and then between 2 and 3, I would put a bar at 1 there, and then here would be a bar at 2, and then you make your histogram that way. Task 3, we're going to look at finding the quartiles and stuff like that. So to put the numbers in ascending order, that just means from least to greatest. Again, have the students do that by hand, but I'm going to go back here and look at some cool things that you can do. So 1, you can use Python to sort those. So if you do sleep of class sleep hours and sort them, here's that data sorted from least to greatest. So that's very useful. I know as a student, I would make mistakes or take a while in sorting values from least to greatest, especially as the data sets got larger. Here, to find the descriptive statistics, you can find the minimum, first quartile, median, third quartile, and maximum quite quickly. So you can put in the answers from there to put the values in ascending order, and then your minimum, first quartile, and so on. Again, here is the sorted values. This is your minimum, first quartile, median, third quartile, and maximum. And then you can make a dot plot below by just putting the values there, like 2, 3, 4. And if there's a number in the data set that has that, you just put a dot above it. So this just kind of goes through putting those figures in there. Here, to create a dot plot of this data set, that is also in here. So what I did for this part, I created a vector called score. I did not put it in the data set. I just put those in as a list. Then I made that into a data frame. So I put a values vector, just put an array of score of 0 dot unique, and that gave me the unique values of that. To create a count here, I did a count of the unique values. So I just put in my own count here. So if you notice, I put a values here, and then I did a count here to kind of make a data frame, which was in the original problem. Then I did a scatter plot of the values and then the count to create sort of a dot plot. Traditional dot plots would have 2 would have 1, 2.5 would have 1, but for 6 you would see a 1, a 2, and you would see actual 3 dots here that just didn't have a graph that I could find in Python that did that. So now to create a histogram of score, you do score.hist, and it did a histogram of the first column of that. To do a 5-number summary, you can do score.describe. And what I can do the descriptive statistics. So it did a count of like 30. I would do score of, we want the 0 column. So let me put that in, score of So let me actually just quick change this into a pandas data frame. So now that I've done that, what I'm going to do is put score of, and I'm going to start listing the columns. So I'm going to type in score to kind of see what the names of the columns are here. So if you are kind of wondering what I'm doing there, that's what I'm doing. So I'm going to put score dot describe, because there's only one column here. It has a 0 column of that. So on there, it listed the different values I had there. so that you can find the descriptive statistics. Then on here, if I wanted to do a box plot of the score, and then just label it the score, and then the title would be the quiz score, you can do that. So we have all of our different values that are listed right there. And then we created the descriptive statistics and then a box plot. And you can also do a histogram. So now what we're going to do is take this value. It's 10 data parts. Find the minimum, first quartile, median, and then draw a box plot. So again here, as I go to that, you can do the shoe size data. Put shoe equals that list. Do a data frame of shoe. Find the descriptive statistics. So you have 10 values. It tells you the mean, the minimum, first quartile, median, third quartile, and maximum. And then you can also create a box plot. So sns.boxplot data shoe. I did a horizontal box plot. And then you can plot the title. If you were to have more than one column, you can just do shoe and then put a bracket of the column that you want. So you can put shoe bracket of 0. So parentheses, we want the 0th column. And then it wasn't named 0. That's why I had to take that part out. So it's the 0th column, which is a counting of that. So that was the numeric data visualizations. And also, as always, there's different ways to do these. If you're to Google how to make a box plot of this data in Python, you can find different methods for doing each of these techniques. And oftentimes there's different ways in different Python libraries to do that.